Well, let's look at the theories of theories. The kinetic molecular theory. This helps explain a lot of the different ways and things we see when it comes to particles. We focus mostly on gases instead of solids and liquids, although we will explore a little bit of that as we go throughout the year. So, the common assumptions. Particles of matter are always in motion. That goes meet the states that we're above absolute zero, meaning things are going to be constantly moving towards us. Individual particles, volume is equal to zero. That's not the case. However, we assume it is to make things easier to discuss. However, this makes a component of why things don't always work out, is that very, very large gases are going to have a substantial volume in which that's going to affect what we see. Pressures caused by the collisions of particles within the container's walls. This is the idea that things are pushing on the containers, and those are going to be pushing back and able to giving us pressure. No attraction or repulsive forces. This is the biggest assumption that'll change when you have a real gas instead of what are they called ideal gases, where they fit these assumptions. And average kinetic energy is proportional to the Kelvin temperature of a gas. So these are related. When one goes up, so does the other one. So laws help describe what we see. So we see that pressure is force divided by an area. Theories help explain. So they constantly move around, collide with the walls of the container, exerting force over that area. And that this pressure can be pretty constant, even though not all of the walls, not all of the particles are hitting the sides of the container at once. Boyle's law, inversely proportional. If the volume is decreased, cause more collisions in a given time, force is equal to pressure, so this will increase the pressure. Volume is proportional to temperature. Increasing temperature, move faster, collide, more force, should increase pressure. However, for pressure to stay the same, the volume would need to increase because of the volume-pressure relationship that we see in Boyle's. Avogadro's, proportional of moles and volume. More particles, more collisions results in more pressure. But to remain constant volume, it would need to increase. So the volume would need to increase because of that, because we have more particles. Dalton's, they're all summative. Each gas acts like an independent one. So particles have negligible size and don't interact with each other. So they only differ by mass. And we know the kinetic energy is related to temperature. That means although the gases may have different masses, they move at different speeds. And that means they're going to collide with the container with the same force. Right? Because it's the kinetic energy that delivers that force when they collide with the container. In the ideal, there's a much more complex derivation in the book. Uses all the others to solve for what's a perfect idealized gas, but of course it has its own pitfalls. And we'll see those deviations, not derivations, deviations in our next component. All right, come in with any kind of questions you got. I'm here to help. Take care.